Brand new chapter. Brand new stuff we're learning. We're doing polynomial functions, you guys. So, first of all, a definition of a polynomial. Let's just break down that word. The first part is poly. Many. Yep. Nomial or nom. Yes, I am. A number. Many numbers, okay? So, this one has many, many terms. It has to have more than one term to be a polynomial. Okay? So, for instance, the number n is the degree of the polynomial. So that's what this is right here. Okay? That's the highest number of the exponents. Okay? All the a sub n's are the coefficients, the number in front of the variables. Oh, lost my pen. Polynomials of degrees 0 through 5 have special names, and here they are on the right. Okay? If it has a degree of 0, it's a constant. It's just a number because there's no variable there when that. What happens when you have anything to the 0 power?
1.
It becomes a 1. So if I had 2 to the 0 power, that's just 2. 2 times 1, right?
I thought it was
2
just,
times
doesn't anything
x.
to 0 power equal 1?
Yeah, but this 0 only applies to the x.
Oh,
Yep. Okay. So,
Wait, but isn't 2 times 0?
all right. Anything to the first power would just be a plain x with a number in front of it. So an example of this would be like 4x. Okay, that's to the first power. Anything to the second power is a quadratic. Here we are. Okay, to the second power. To the third power is cubic. Fourth power is quartic. And fifth power is quintic. So you guys see that this is to the fifth. This one's to the fourth. It's not necessarily in the right order.
does it matter order or something?
Well,
All of these are polynomials.
yeah, all of these are polynomials, and if you write them in standard form, it should be in order from highest degree to lowest degree. If that's in standard form, okay?
Okay, wait, I don't understand the first one. How is that to the 0 power?
This one right here,
Yeah.
this would be like 2.38 times x to the 0 power,
Okay.
okay?
Why didn't it write that?
Because x to 0 power is 1, and it disappears. Okay, good question. Okay, the standard form of a polynomial is written where the exponents are in descending order. Okay, written. Okay, I'm going to take out the n where the exponents are written. Okay, I guess you could say in descending order. Okay, so for instance, let's look at the quartic one. Notice that it's going from lowest degree to highest degree. If I wanted to write that in descending order, I would write it as t to the fourth minus 81t to the second plus 0.7.
So the number 5 is in standard form.
Number 5, the quintic one is in standard form. Yep. And so is the cubic one. Okay? Those are in standard form. But anytime it's not in descending order, it's not. A company wants to produce an open top box from a 60 centimeter by 45 centimeter piece of cardboard. And they want the box to have the largest possible volume. The picture shows the way the cardboard will be cut and what the box will look like after it is assembled. Okay? So, first it says, write the equation for the volume V of the box in terms of x. Use your expand feature on your cast. Well, we don't even have to do that. I'm going to show you. So, first of all, how do we find volume? Length times width times height, right? Okay. So based on that, what is my length, my width, and my height on here?
Your length
Okay? And this is my width.
Width is 45.
Okay, so let's write this out. My volume would be then my length, which is 60 minus 2x. And my width would be 45 minus 2x times x. Can you guys agree with that?
Wait, is that okay? Yeah.
All right. Now, I'm going to save us.
Can you put X in the 45?
Why would you take away?
Why wouldn't it just be 60, 45? Because that's
Oh,
the
because of the
square.
corner.
Mm-hmm.
So can't you insert X?
I'm not going to do it right now. You want me to? Okay. So, if I'm going to multiply this out, I'm going to leave my x out right now. Let's just multiply it out using the box. We have 60 and minus 2x right here. I'm going to just show you in a minute. This is a way you can multiply it out. So notice I have 60 minus 2x, 45 minus 2x. Okay, what is 60 times 45? Yeah, 60 times 45 is 2,700. Okay, 60 times negative 2 be negative 120 x. 45 times negative 2 would be negative 90x. And negative 2x times negative 2x. Yeah, that's a plus 4x squared, right? Okay, what can I put together there?
The 90.
Yeah, I can put those two together, right?
Can you just FOIL them?
Yeah, you can FOIL them too, but I wanted to show you this method. Yes. So, this is going to be 2,700 minus 210x plus 4x squared times x. So what is our total volume on this? Yep. Mm-hmm. Now, is this in standard form? No, it's not. Okay? If we wanted to write this in standard form, we would go 4x to the third minus 210x squared plus 2,700x. Okay? So that is our formula. Okay, so now, it says for what values of x does v have meaning in this situation? I want you to look back at the factored form right here. What values of x would not work? You don't want any of these to equal 0, right? So x cannot equal 0 itself. What else can x not equal? Well, one way we can find it is we're going to take this factor, 60 minus 2x, and set that equal to 0 and solve. Okay? So if I subtract 60 from both sides, I get minus 2x equals minus 60. So x is 30. Okay, so it can't be 30. What else can x not be? So we're going to do the same thing here. 45 minus 2x equals 0. If I subtract 45 from both sides, I have minus 2x equals negative 45. X cannot equal then, if we do this, it'll be 22.5. Okay. Okay. So, there's 3 numbers for sure that we know that x cannot be. 0 makes sense.
What did you do for those?
I just took my factors, each of these factors, here's one of them, set them equal to 0. Because if one of them's 0, the whole volume's 0.
What do you mean if one of them is 0?
If 60 minus 2, if I take 30 and put that in there, it would be 60 minus 2 times 30. Then it would be 60 minus 60. It would turn into a 0. So 0 times anything else is 0, right?
Oh wait, so if 60 minus 2x equals 0, then the other one would be 0 because you're multiplying by it?
Right, right. So we don't want our volume to be 0 or we won't have a box. Okay? So these are the numbers it can't be. We know that x has to be larger than 0 And what does it have to be smaller than? 22.5. I'm picking the smaller one of these because of the fact that if it goes over this one, it's going to be 0 for this other one anyway. Okay? So this, by doing that, we found out what our limits are for our x.
So do we always think this one, or the smaller one?
Yeah.
The more limited.
Okay? So it says replace x up here from step 1 with 10. What is your answer represent? So let's do that. If my volume of 10 is 2,700 times 10 minus 210 times 10 squared plus 4 times 10 to the third. Okay, that ends up being, I think I got 10,000. You have a question?
Is that for the 10, are you only, so you're only doing the 10, right?
Yep, just doing the 10. I'm replacing the x's with the 10 here.
Right.
Wait, can
Is
you
that
slow
not,
down a little bit?
What's
Sure.
2700 times 10?
that's not quantity squared. It's not the quantity of, like, say, 2,700, or, 210,
200.
10.
Okay, so it's telling us that the volume at where x is 10 is 10,000, right? Okay. Okay, so now it says graph your equation from step 1 and use your answers from step 2 and 3 to appropriate the window. Okay, so first of all, our x values. Our minimum is what?
0.
Okay, our max is what?
22.5.
22.5. Okay, now here's what here's why we use 10, you guys. We have a y minimum is what? Can we have a negative volume?
No.
No, so it's going to be 0. What is our y max going to be at least?
10,000.
At least 10,000, so pick maybe a little bit over that. Let's say 11,000, okay? That's why we did that, okay?
Oh, because we had to find, so step 3 is to find y.
So if I put that into my equation here, I'm going to put 2,700 x minus 210 x squared, right? Plus 4x to the third. Notice that you can't see anything on it. It only goes to 10. We're dealing with thousands, right?
That's why you gotta go to 11.
That's why we need to go to our menu, go to our Windows Zoom, go to our Windows settings.
And then you have, as a minimum of 0.
Yes.
And
Yes.
a maximum of 22.5.
Yep.
And then a minimum of 0.
Okay.
And then a maximum of 11,000.
Yep. Okay. So if I put this in here, I get this.
Go from the other side, so you're not.
All right. Watch. If I use the trace, okay, and then I take my button, and it will actually say max at some point. See?
Yeah, but I feel like that's not accurate. Like, you can always just do analyze graph, blah, blah, blah.
You could do that too.
Wait, how do you do the analyze graph? I'm like, wait,
Okay, so to describe the graphs of polynomial functions, it helps to know their maximum and their minimum and their intercepts. Okay? So, example 1, it says, let p be the polynomial function with equation p of x equals this. Okay, yes?
What's the answer to step 5?
Step 5, what is the maximum point of the graph? Oh, going back to that, that's back at right here. Our maximum here is 1.02 times 10 to the 4th. Okay, so 1.02 times 10 to the 4th. 1.02 times 10 to the 4th So now if I were going to put that in, it'll be 10200, okay? So our maximum volume is 10,200. Huh? That's the maximum volume we can get out of the box that size. Okay?
How did you find that?
Because we found that on our graph right here, the y value,
Yeah.
1.02 e to plus 4. That means 1.02 times 10 to the 4th. Okay?
And then you did all that.
So when I put that in here, it'd be 10,200.
Yeah, but what about the 8.49
That's all right.
That's the x value. I needed to find the y value.
for the max?
Yep, for the maximum. Okay, now back to this. What is the degree of this polynomial?
3.
Well, one of them's 3. What's the other one? 2. So if I were to multiply x to the third times x to the second, that would be what?
It's 5.
Yep, so it's 5. Okay?
Oh, because you added it. Right.
Yep.
Wait, you add them and multiply?
You add them. You add the exponents. Okay, find the y-intercept of its graph without graphing it. So if you put in a 0 for x, you end up with negative 1 to the third and 4 to the second, which happens to be negative 16. That's your y-intercept. Okay? Find the x-intercepts without graphing. Well, in factored form, that's your x-intercepts, and they've already given us this. So all you need to do is set each one of those to 0.
What's your factor?
Right here. They told us it at the very beginning, right here and here.
That's factor?
That's in factored form, yep.
Oh.
Okay? So if I set them both to 0, what's my x? You have 2 of them, right?
Negative 4 and 1.
Negative 4 and 1. Okay, so that's where this particular graph crosses the x-axis. Okay? So this is my x-intercepts, and these are my y-ends. Okay? All right, I want
Wait, what does that say?
x-intercept, y-intercept.
What's the little thing in between?
Oh, it's an arrow.
That?
Sorry. Okay, I want you guys to take a minute and try to figure out the next one. See if you can do it on your own. Okay, so we're trying to find the degree. You're right, there's a secret little 1 sitting here. It didn't show. Okay? So in a sense, this is going to be x to the 1 power. This one's going to be x to the 3rd power. So what is our total x is going to be?
4.
To the 4th power. So our degree is 4. Okay? Now, did I need to worry about their coefficients in this case? No, not important to find the degree. Okay? Find the y-intercept of the graph without graphing. So I'm just going to put in for 0 for x. So 0 plus 3 to the 1st, and 0 minus 2 to the 3rd. Okay, because 2 times 0 is 0, right?
So then, shouldn't it be negative 3?
Where's this is positive 3.
No, I mean the whole thing. The whole thing equals negative 3, right? I got 3 times negative 2 to the 3rd.
3 times negative 8, because negative 2 to the 3rd is negative 8.
Right.
Yep.
I did 2 times.
And this will be negative 24.
Oh, yeah.
Okay? Now it says find the x-intercepts of the graph without graphing. What do I need to do? Set them equal to 0. So 2x plus 3 equals 0.
I got negative 3 over 2.
Yep, negative 3 over 2 is the first one. And Ariane, what, you have a question?
Where's your pen at?
Yeah. Mm-hmm. Right. Ariane, 2 times 0 is 0, right? 5 times 0 is 0. That's what happens to them. They zero out. And then this one is...
Worry about the next one for this one again?
Nope. You just don't need to. This is where it's going to cross the x-axis.
How you would
Okay? The maximum value of a function is its largest value in its range. Range, remember, is y values, okay? The minimum value is the smallest function, or smallest value in its range. These are the extreme values of the function. Functions also have relative extrema, caused from little bumps or hills in the road, so to speak, okay? So, if you look at the following graphs, this one has no maximum, because if you look at it, goes from here, it goes on up forever. It has no minimum, because it goes down forever. But it has two bumps in the road, right here and here, right? So this one's a relative maximum. A is a relative minimum. Make sense? Okay. Number 2, we don't have a maximum again. But what is the overall minimum? C, yeah, because that's the lowest point it goes. And then we have a bunch of relative ones. For number 3, we have no minimum, but we do have a maximum, and that's at H.
Wait, why is C, for the second one, why is C a minimum and a relative minimum?
Good question. I think any minimum can also be a relative minimum. Yeah.
For the ones with the multiple relatives,
Yep.
do you list all of them, or can you just list the relative ones, relative numbers?
Usually you list all of them, because this is how you know how to graph it. Because if you get those points, you don't have to get the numbers in between exactly if you're hand graphing them.
Okay.
So it makes it a little easier for you. Okay. This one has no max, no min, no relative. Although, I think if you were to zoom in on this and really zoom in, it would do something like this. I would argue it does that. Okay. But from this appearance, it doesn't. This is a cubic, so it really should have a relative minimum and a maximum. Okay. Any questions on that? All right, you guys are doing great. All right, so last page. Consider the graph f of x equals x to the third minus 5x minus 2, shown at the right. A relative maximum occurs when x is about negative 1.3, that's right here, and a relative minimum is at where x is equal to about 1.3. Okay? So, tell me the intervals where f is increasing. Give me the intervals of x where f is increasing.
Between
What is
negative
F?
1.3
Wait, oh, you mean
and
F
whatever.
of X?
Yeah.
The Y values?
So, from negative infinity, I'm looking at the x values, so at the farther out I go, it's rising up until I get to what value of x?
1.3.
Okay, so, okay. Okay, what else, where else is it rising?
Negative 1. No, negative
Wait,
1.
why
Oh,
did you
you're
say
right.
the value of X? I thought we were looking at Y
I'm
values.
so confused.
Okay, good question. I'm looking at the y values, yes, but I'm saying from what x value to what x value is it rising?
Oh,
Okay, so from here to here, it's rising, right?
1.3.
Because infinity.
Yep, from here to here, it's also rising. Okay, so 1.3
X.
less than x.
And then, wait, and then to infinity, right?
Yep, to positive infinity.
And
Okay.
then it's decreasing from negative 1.3 to
Yep.
X to 1.3.
Good. That makes sense?
Shouldn't it be the other way?
This one says consider the graph of negative 2/3 x to the fourth plus 3x to the third minus 5x. And here's the graph over here. Using letter labels, in which interval is h negative? Okay? So, when is h negative?
Wait, in terms of X or what?
So,
When is the Y value negative at intervals of X or
Yeah, intervals of x. X is negative here.
G to infinity.
Infinity to A,
Yep.
and then C to E.
So x less than a, it's negative. Where else? C to what? E.
C to E.
C to E, yeah.
Okay, and then x greater than g, right? Okay, tell me where is or where is h positive?
A to C.
X is between a and c. And then x is in between what?
E and G.
Yep, E to G. Okay? Now be careful with this, okay? It's just a little bit different way of wording it. Okay? Okay, we're almost done. Here we go. The zeros of a polynomial function are the spots in which the graph crosses the x-axis. It's also known as x-intercepts, guys. X. Huh? Yes. When working with polynomials of degree 1 in the form of ax plus b, the zeros can be found by setting f of x to 0. I know. I know. When working with a polynomial of degree 2, you can use the quadratic formula. However, for polynomials greater than degree 2, there's no easy formulas. One way to find the zeros would be to graph the function. A more accurate way is to use your calculator to find the relative minimum and maximums, which you saw, Monet showed you how to do that a few minutes ago. Okay? But here's how you would use your calculator. You can type in zeros and it can tell you. Okay?
Why do you